Okay, today should be a review from geometry your sophomore year. I'm guessing you guys will be able to do just fine with it. And what we want to do is instead of do trigonometry with the unit circle, we'd like to do trigonometry with right triangles. And so I have a right triangle here, and the first part that we need to do is we need to identify certain parts of the triangle. You can see that theta is listed for you. Theta is the angle measure that we're referring to, which means that this side right here we're going to refer to as the hypotenuse. The hypotenuse is the side opposite the 90-degree angle. It's also the longest side in a 90-degree triangle. We also have a side that's referred to as the opposite side because it's across from the angle. And then we also have what we refer to as an adjacent side. And the adjacent side you can tell, the red dots that I have, actually I'll make it a red line. This red line is the angle, correct? That's theta. So the adjacent side is the side that helps make up the angle. So the hypotenuse and the adjacent side make up the angle. The opposite side is the one across from the angle. It has nothing to do with it. Are there any questions about the terms or definitions that we've used so far? Then let's go back to our definitions from geometry that you learned a long time ago. Namely, you use this acronym SOHCAHTOA. This is not how I remember these. If that's how you remember it, that's fine. You can do whatever you want. But using this frame of reference, we know that sine can be written as opposite over hypotenuse. Thus, you see the SO. Sine is opposite over hypotenuse, S-O-H. Raise your hand if you've used SOHCAHTOA before. Okay. So, cosine, please do not refer by first names. Cosine would be adjacent over hypotenuse. And tangent, opposite over adjacent. Okay? The others are simply the reciprocal. If you take the reciprocal of cosecant, you should get the hypotenuse divided by the opposite. You would get the hypotenuse divided by the adjacent, and you would get the adjacent divided by the hypotenuse. I'm sorry. Are there any questions about where these definitions come from or these ratios? Okay, let's put it to good use and get some practice. It says find the exact value of the 6 trigonometric ratios of the angle theta in the right triangle. So I have a right triangle here. Again, this only works for right triangles. We do have another study in trigonometry where we do oblique triangles, which we'll do next week or so. Well, actually in a month. But what we want to do is we want to write our expressions given these pieces. So I do have, is 5 the opposite, the adjacent, or the hypotenuse? That's the opposite side because it's opposite the angle. 13 is the hypotenuse, and I don't have the adjacent. How would I solve for the adjacent? The Pythagorean theorem, so I would have x squared plus y squared, or 25, is equal to c squared, which is 169. Subtract the 25 over, x squared is equal to 144, x is equal to 12. So you can see that we're out of the unit circle because our radius isn't 1 anymore. Our radius or hypotenuse of this triangle is 13. And so now I should be able to write all 6 trigonometric ratios. Sine, cosine, tangent, cosecant, secant, cotangent. Sine of theta is 5/13. Cosine, 12/13. Tangent, 5/12. And then cosecant, secant, and cotangent would be reciprocals. So all I've done is I've just used my ratios in order to express them as the trigonometric functions. Any questions on that piece? I knew right away that it was 12, and these could be helpful to you. If you remember some of the Pythagorean triples as they're referred to. 3, 4, 5 work. 5, 12, 13 work. 8, 15, and 17 work. 7, 24, and 25 work. 4, 41, and 4, 40, and 41. 9, 40, and 41 work. There's an infinite number of Pythagorean triples, but I suppose that those are some of the more common ones that you would see. So, and any factor of them work as well. So if 3, 4, 5 work, then 6, 8, and 10 work as well. But I'm sure you guys had that ingrained in your head, right? Very good. So we move to a different scenario here. It's just find the exact value of 6 trig ratios given this. So now I have 2 and 4. How do I find the hypotenuse? Pythagorean theorem. 2 squared plus 4 squared is equal to c squared. So 4 plus 16 is c squared. 20 is c squared. So c is the square root of 20. Can you reduce the square root of 20? So c is equal to 2 square roots of 5. Now, before I list all the trigonometric ratios, well, we'll list them, then we'll actually find them. I know it may feel repetitive, but take joy in the fact that you know how to do the problem. Yeah, it takes a little time to write all these down, but at least you know where you're going. A lot more frustrating to have, say, just one problem, but take 2 hours to do it. So, okay. So at least we know what we're doing. We have our 3 pieces. Now I just need to identify opposite, adjacent, and hypotenuse. I know that 2 square roots of 5 is the hypotenuse. But which one's the opposite side, 2 or 4? Why 4? Because if you look at theta, 4 is directly opposite it, okay? This is the angle, and you can see that 4 is opposite the angle. So, what would sine be? 4 over 2 roots of 5. Now, you can't have a square root of 5 in the denominator, so you need to reduce this as such. 4 over 2 roots of 5 is the same thing as 2 over the square root of 5. And how do I simplify that? Top and bottom by the square root of 5, so I would leave it expressed as 2 roots of 5 over 5. Please go ahead and take about 3 minutes, and please finish off those 5 ratios. Go ahead. Are these right? Is that what you got? Okay. All right, very good. Let's go to the back side. Okay, solve for the missing side of the triangle. And as you see this problem here, what we're looking for is we need to find x. And that's one neat and applicable thing about trigonometry is that you're able to solve for things that you otherwise wouldn't be able to do. So normally if you had just one side and you were trying to find another, you would maybe say, well, I want to use the Pythagorean theorem. Well, for the Pythagorean theorem, you have to have two sides. Well, with trigonometry, if we have a side and an angle, we can find the other sides. So that's fortunate for us. So we want to be able to find this x. You will always choose either sine, cosine, or tangent. What we need to be able to do is select the correct one. And in order to select the correct one, I need to look at my angle and then look at the side that I am given and the side that I am trying to find. So what is 9? Opposite, adjacent, or hypotenuse? Opposite. And x is hypotenuse. So which trigonometric function has to do with opposite and hypotenuse? Sine. So we set it up. The sine of the angle, namely 42 degrees, is equal to the opposite side, which is 9, divided by the hypotenuse, which is x. Now, you do it however you want, but this is the way that I will teach it. Every time I come up with a ratio, I always write it over 1, and then I cross multiply and I solve. So I have 9 times 1 is 9 equals x times the sine of 42. In order to solve for x, what would I do to both sides? Divide by the sine of 42. So if you take out your calculator and first of all hit mode and see whether or not you're working in radians or degrees. As you can see here, I'm working in degrees. The third one down says radians and degrees. You will come up with completely different answers because 42 degrees is completely different than 42 radians, right? And 42 radians is like 6 times around the circle, whereas 42 degrees, well, that's not even 1/8 of the way around the circle. So you need to really specify which one you're doing so that your calculator knows what to do. So I'm working in degrees. So what I'm going to do is I'm going to take that 9 and divide it by the sine of 42. And when I do that, I get 13.45. Let's do a check. If the opposite side is 9, would it make sense that the hypotenuse is longer? Yes. So that doesn't tell us for sure that we're right, but it does tell us that, we're in the ballpark. That's reasonable. Let's do the second one together. You can do the third one on your own. 14, is that opposite, adjacent, or hypotenuse? 14 is the hypotenuse. How about x? Adjacent. So which do I use? Sine, cosine, or tangent? Cosine. Cosine of 63 degrees is equal to what? X over 14. I write it over 1. I cross multiply and solve. X times 1 is x equals 14 times the cosine of 63 degrees. So I go to my calculator, 14 cosine of 63, and I get 6.56. What? I'm sorry, 3.6. Here I multiplied. You can see x times 1 is x. So I have 14 times the cosine of 63. Please do the last one on your own. For the last one, you should come up with x is equal to 9.4 times the tangent of 27. What is 9.4 times the tangent of 27? Any questions on those three problems? Okay. If you guys understand that so far, then you should be good to go all the way. Let's finish off these last pieces here. Okay, so the confusion was the other day in regard to triangles as we sketched them. People were wondering, well, how do you know if you're working in the unit circle or not? This one word here, it says sketch a triangle. It doesn't say sketch the triangle. If it said the triangle, then there would just be one triangle that exists. But we just want to sketch an example of a triangle that has an acute angle that satisfies that. And then we want to find the 5 trigonometric ratios other than sine of theta. Now, this isn't really going to be that difficult, but I want you to understand that the other day we were kind of restricting ourselves to the unit circle. Today we're not. And we just have to give one example of a triangle that fits this. So, sine of theta is 3 over 7. Tell me, sine of theta is equal to what? Opposite, adjacent, hypotenuse. What is it? Opposite over hypotenuse. So what I can do is a triangle, not the triangle, but an example of a triangle would be something that looks like this, where I have theta. The opposite side is 3. The hypotenuse is 7. That's one example. There's infinitely more. You could have 6 and 14. You could have any multiples. But this is one example. In order to write all 5 trig ratios, such as sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta, we know that sine of theta is 3 over 7, and we know that cosecant is then what? 7 over 3. In order to do the rest, what do I have to find? The missing adjacent side, and so what do I use? Pythagorean theorem. So, namely, 3 squared, which is 9, plus x squared is equal to 49. Subtract the 9. X squared is equal to 40. Square root both sides, and I get x is equal to the square root of 40, which reduces to 2 roots of 10. So x is 2 roots of 10. Now, once you know x is 2 roots of 10, can you take care of the rest? We've already practiced that, so let's move on, okay? As opposed to filling in all these, you now know x, you know the diagram, you can do the trig ratios later, okay? You don't have to do them here, but I think we all understand, right? Okay. This problem is incorrect. Secant can't be 9 over 10. It's 10 over 9. Okay. Now, what is secant in terms of sine, or in terms of opposite, adjacent, hypotenuse? So we have a hypotenuse of 10, and we have an adjacent side then of 9. Okay? And so as I construct a triangle that fits that mold, I need to find which side? The opposite in order to do all of them. In order to find the opposite side, I will use the Pythagorean theorem. The opposite side we'll refer to as, doesn't really matter, we'll call it y squared plus 81 equal to 100. Subtract my 81, I get y squared is equal to 19. Square root y squared. Y is equal to the square root of 19. And again, you could write all 6 trigonometric ratios now once you have that. Okay, we'll finish off with 2 application problems. Anybody fly kites here? Nobody? Okay, so we'll draw Nathan. This is Nathan. Here. Okay, there's Nathan. Nathan's flying a kite. At a 36-degree angle It says he has 500 feet of string let out. So which part of the triangle should I label that as? Hypotenuse. Now I know there's going to be some sag in the string, right? It's going to dip down, but hard to account for that. So we'll just call it 500. And the question is, how high is the kite? Okay. Kite's flying at an angle of elevation, so that's what it means they have an angle of elevation. From the horizon, you rise up 36 degrees, 90 degrees, 500 feet. How high, so we're looking for this h, is the kite flying? Somebody give me a trigonometric ratio. Very good. Sine of 36 degrees is equal to h over 500. Cross multiply. H is equal to 500 times the sine of 36, which is what? 294? Point. 293.89. A couple people second hour brought up a good point. They said, well, Mr. Gantz, if he's holding it with his hand, then, you know, that would be an extra, say, 4 feet or 5 feet off the ground. That's correct. A tree is 10 feet tall and casts a shadow of 7.3 feet. What is the angle of elevation of the sun to the horizon? So if I can, you know, kind of give you just a little descriptor here. We have this sun, and we have a tree. And then we have a shadow. And the tree is 10 feet tall, and the shadow is 7.3 feet long. And the question is, as you're standing on Earth, you know, at what angle of elevation is the sun in the sky from the horizon? So if we look straight out into the distance, you know, what angle of elevation would we have to raise up to see the sun? You know, because the sun casts that shadow. And so really what we're looking for is theta. So what makes this problem unique, is that we have the two sides. We need the angle. Well, can you write a trig ratio that relates these pieces together? What? Tangent of theta is equal to what? 10 over 7.3. Now, we haven't talked about how to solve for an angle, so I would like to show you something that's going to connect with your previous knowledge, that's going to help you understand why we solve for it that way, and this is our last step. If I give you this equation, 1/2 x is equal to 3, you solve for it by doing times 2 over 1, right? And you do that because that operation, they are inverses of one another, right? And if you have something like this, the natural log of x is equal to 5, how do you get rid of the natural log piece? You raise each as a power of e, and that will get rid of that because those are inverse operations of one another. You'll be left with x is equal to e to the 5th. Well, the same thing happens with trigonometry. Some people said, well, can we take the cotangent of both sides? That's not what happens. You don't take the cotangent of both sides. What you simply do is you take the tangent inverse of both sides. So I'm going to write this out, and this is the only time I will write this out. You won't do this in the future. If we take the tangent inverse of both sides, so that's mathematically what I'm doing. I'm taking the tangent inverse of both sides. When I take the tangent inverse of tangent of theta, what do I have left? These are inverse operations of one another. You're just left with theta. Now, a lot of people said, well, Mr. Gens, tangent inverse, that's just cotangent, isn't it? No, this doesn't mean 1 over tangent. It doesn't mean the reciprocal of tangent. It's not tangent to the negative 1 power. It means inverse operation. It means to go from a decimal to an angle. So theta equals the tangent inverse of 10 over 7.3. And if you look on your calculator, you have this handy-dandy button right above tangent. So if you go second tangent, that's tangent inverse. So my tangent inverse, 10 divided by 7.3, and I get 53.87 degrees. Any questions how I got that? If we review, you know all these definitions? Given two sides, can you find a third and write all 6? Given a missing side and a given angle on the side, could you solve for them? We've already kind of covered that, and hopefully you're good with this piece as well. So I think you should be good to go. Tomorrow you're going to get a full day to work, and I will write the assignment on the board. Page 489, 3 through 6, 9 through 14, 18 through 20. If you'd like to get started now, that's fine. If you'd like to wait tomorrow, that's fine. There's more yet. I didn't add the word problems yet, so I got to... Okay, so this is the complete assignment. I didn't quite get it all up there for a second hour. There it is, and you can start on that.